In this video, I am going to show you how you can run bioinformatics analysis using your internet browser. The only requirements are to have an internet browser and an internet connection. We are going to use the web platform called Galaxy. This is the page, and I will leave the link to this page in the description box. For those who don't know, Galaxy is a web-based platform that is used for designing data analysis workflows. These workflows can be used to analyze biological data as well as for data integration tasks. Galaxy comes with lots of bioinformatics tools, and one cool thing about this platform is that it allows users without programming experience to use the tools with ease. All that you have to do is to upload your data, select the tool or tools, specify your parameters, and execute the task. This video is an introductory one, so what we are going to do is to explore the Galaxy platform, and then I will demonstrate how to perform an analysis on this platform. You can use Galaxy right off the bat, but I highly recommend that you first log in with your user credentials. This makes it possible to save your work as well as data that you have uploaded or gets generated. And so if you want to log in, you come to this side here. So it's login or register. If you don't have an account, still use this particular button here. Click it, and then you'll be sent to the login page. So on the login page, if you have your account, just type your username or email address and the password. If you don't have an account, just click on the register here, this side here. So click it, and then you'll be given this form, the registration form. So just enter your email address, the password, and the public name, and you can create the account. Okay, so that's how we do it. After you have submitted the registration form here, a link will be sent to your inbox. Okay, the email address you used to register, you receive a link in that email, and then you have to use the link to activate your account. And so make sure after registering, you check the email, get the confirmation message, and then click the activation link. After that, you can log in and then start the Galaxy exercise. So I already have an account created, so I'll log in and then I'll proceed. So make sure you have also signed up, obtain your accounts, and then you have also logged in. So let's get started. Okay, so after a successful login, you will see this page. On the right side is your history. If this is the first time you are logging in, then the history will be empty. If you have used Galaxy before and you have performed some activities, then it's likely there will be some history here. So an example is this one here. This is another account that I have. Okay, so I have performed some analysis, and so this is the recent history, the most recent. Okay, if I come to this side, I can click, and then Galaxy will show me my history, all the activities I have performed. Okay, some of them I performed them over 2 years ago, some of them about a month ago, and some of them I just worked on them. So that's the history. So if you have used Galaxy before, then you have this there. So that's about it. Now let's switch back to the other accounts. So on the left side, you can search for tools. Okay, so there are lots of tools available here. Okay, so these tools, most of them are command line, but then with Galaxy, you don't need to type any command. You just have to select the tool. So let's say, for example, you want to perform assembly, you can click assembly and then select some tools that have been labeled here. So let's say spades. You can just click it and then it will be shown for you, and then you can upload your data and then also select some parameters here. Okay, that's about it. Now the tools themselves, you can also search. Let's say you want to search for some tools. You can search for it, and then if the tool is available, then it will be shown for you. So some tools When you click on it, you have all tools that have the name SAM tools included. So let's also use BCF tools. When you type it, you have the BCF tools also here. Okay, so I think these are the BCF tools options. So you just have to select the appropriate one and then use it. So just search and then you will be able to get the tools that you want. Aside that, you can also upload your data by using this particular upload button here. Okay, so when you click on it, you have this window appearing and then you can select the data that you want. So you can upload data from your computer and then you can also import data from a remote server. These are things we will cover in later tutorials, so take note of that. We will come back to the upload button soon. You can see that the space tool is still showing. Okay, so if you want to go back to the home page, you can just click on Galaxy here on the left and then you'll be sent to the home page. So in case you select a tool and then you want to change the tool or you don't want to run the tool at that moment, then you can just click on the Galaxy text here and then you'll be sent to the home page. When you come to the menu here, we have workflows. So when you click on it, at the moment I don't have any workflows. Okay, so what you can do is to select workflow. You can search workflows here by their names, or you can also create workflows, or you can import. These are things that I'll cover in later tutorials. You can also look at visualization, where you visualize data sets. You can also look at shared data. So the shared data here, we have data libraries, histories, workflows, visualizations, pages. So these are things that are shared. So if let's say another user has a workflow or data, then if the user has made it shareable, then you can just go to any of these sections and then select the appropriate resource that you want. There's also a help section. There's also the user section. So here you can change some preferences. You can log out. If you have data sets, you can click and show histories, etc. So just need to explore. Okay, so I just make sure you explore all these things. This tutorial is just an intro, so I'll not go into details with the Galaxy platform. There's also the release notes. We also have training materials, and then we also have enable disable window manager. But these are things you can also explore on your own. So this is just about the summary that I want to give with the Galaxy platform. Now, let's test Galaxy. We are going to run an example analysis. So let's go back to the home page now. Okay, we are now ready to test Galaxy. So what we are going to do is to perform genome annotation using the tool Proca. And so we need to first name this activity that we are going to do. Okay, so that is where the history comes in. So on the right side, you can click on this plus button here to create a new history. So you click it and then a new history will be open. By default, the name will be unnamed history. So you can edit it. So let's edit it. Let's name this history as genome annotation. And then you can save it. I always recommend that you name every activity you are going to do, you should give it a name. For example, if you are going to perform variant calling, you should give it a name, variant calling. Now we are doing genome annotation, so I named the history as genome annotation. So this helps me to track my activities and it helps me to also locate files easily. Okay, for example, if let's say you've performed lots of analysis and then you want to download the files for one of the analysis, okay, then it becomes easier if you have named the projects or the history. So if you have named them, then you can easily go to this site here, click it, and then select the appropriate history, and then just obtain the files that are there. For example, I have some history here. Let's check. I had one here which is called genome assembly. Yeah, and so I can look at the files that have been generated, and I can also look at jobs that are in queue or jobs that are currently running. So that's about it. So I'll go back to our genome annotation history. By the way, if you want to learn how to perform genome assembly using the Galaxy platform, then you can watch the other video I made. Okay, so the link to that video is in the description box. So just watch that. Now let's get back to our history and select the genome annotation one. Okay, now we are back. So let's proceed. So now we are going to perform genome annotation and we need the example data. The example data is here on one of my GitHub repos. I'll leave the link in the description box. We are going to use this file here. This file here. Okay. This was generated using Spades. This is what we are going to use to perform the genome annotation. So what we need to do is to get this file to our account here on Galaxy. So to do that, we need to click on the upload, and then when you are here, make sure you select the regular here. Then when you come here, we are going to use the paste/fetch data. So this allows us to supply links to files that are on a remote server. You can also choose the local files and then you can upload from your PC if you have the file there. Okay, I have a separate tutorial that shows you how to upload data to Galaxy platform. So in that tutorial, I show you different approaches, so you can watch that video as well. The link to that video is in the description box. For now, let's use the paste and then fetch. And then we also have to give it a name. Okay, so here we are not going to give a name. We will maintain this one because we want the original file name to be maintained. Okay, we want that to be retained. So what we need to do is to paste the link to the file. So let's go back to the GitHub repo here and then just click on spades_config.fasta. Click it. And then when you are here, come to raw. So when you are here, copy this link. Yeah, so make sure you have copied this link, the one that I'm highlighting. That is the download link for the file. So let's go back to Galaxy, and then in this entry box, you have to paste that link. And then that's it. So we will now start by clicking the start button. So spades content.fasta will be downloaded to the Galaxy server. So it's 100%. Okay, that's the status. So that means we are fine. So we can close this one. And then we can check here and then see what is happening. So with the Galaxy server, jobs that are in queue will not be colored. Okay. The background will still be this color here. So with what we have, it's currently queued. So if the job starts running, then you will see the color changing to this other color here. I don't know whether it's brown or orange or something like that. I'm not sure of the color. I think it's orange or so. Yeah. So, and then you also see this wheel moving around. Okay. So this tells you that there's a job running. So the current job we are running is that we are obtaining the spades.config.fasta file. That's what we are doing now. If the job is completed, then we have this green background being shown. Okay, so when the green background comes, that means that the job has been done. So currently we have this green background, so that means that the file has been downloaded to the Galaxy server. So it's now available. So we can now use this file for our genome annotation. And by the way, if you also want to learn how to use the Spades tools for genome assembly, then you can watch my other video. The links in the description box. I've made a tutorial on how to use the command line version of the Spades tool, and I've also made a video on how to use the Galaxy version of Spades to run the genome assembly. So just make sure you watch those videos. So basically, I'm giving you two options. Either you use the command line tool for genome assembly, or you use the Spades, or you use the Galaxy Platform version to run the assembly. So I mean, it works in both ways. If you have few samples, then you don't need to install the tools on your server or on your PC. You can just run it on Galaxy. Okay, and this is also useful if, let's say, um, you are new in the field of programming. Okay, Linux scripts and others. Then just use this web browser and then just upload your files and then do it. But if you have lots of samples, then I recommend that you use command line version, because you can automate the process and then manage things better. Okay, so Galaxy is good, but then if you have lots of data sets, I highly recommend you use command line versions. Okay, let's proceed. So we have the file now. So we are going to perform a genome annotation. Okay, so we are going to use Proca to perform genome annotation. So we'll come to the tools section here, click in the search box and then just search for Proca. P-R-O-K-K-A. Yeah, Proca. And then you can click it and then you specify the parameters. And by the way, I have also made a tutorial on how to use a command line version of Proca to perform genome annotation. So you can watch that video as well. The link to that video is also in the description box. So just take note of that. Now we have context to annotate. This is a file. Local stack prefix. Okay. Here we will leave it blank. Proca has some setting that allows it to automatically assign local stack, but you can also name it. Okay, so for now let's just let's give it a name. So let's just say yeah, for now let's just leave it. Okay, I think we should leave it for now. Proca will give us a local stack, but here if you want you can use a sample name, but it's fine. And then let's scroll down. We are going to use the default settings. Okay, here it says add gen features for each CDS feature. So here you can decide to enable or disable it, but I'll enable it and then add it. We also have minimum context size. So I think we are going to leave all the other settings as they are. And then we just need to make sure that the kingdom is set to bacteria, because the file here was generated from a Mycobacterium ostrans isolates. So that's about it. The rest we will leave them. I think everything is okay now. Yes, so basically if you were to use Proca on a command line, then you have to specify all of these parameters. But Galaxy lets you select them here, and then behind the scenes some commands are executed to get all of them together, and then the activity is performed. So behind the scenes, command line versions of the tools are being used. Okay, so that's what you should take note of. Now let's proceed. So we are going to click on the execute button here to start the genome annotation. So let's click it. Perfect. So once you click it, you also have this message telling you the tool that is being used, the data that is being used, and then the output files. So we have these files. So it says it produces 12 output files, and these are the files. Okay, so that's what we have now. So it has been submitted. So we will wait for the job to finish. So when you come to the right side, you see the files generated, but then because the background is still a gray color, that means that the job is in queue. So we have to wait, and then if there's an available slot, Galaxy will push the job to that slot, and then genome annotation will be done. So let's wait for that to finish. Okay, genome annotation has been completed. So here we can download the files, okay, because these are we have about 12 files here. Okay, so some of them contain logs, some of them contain the gen lists as well as the sequences. Some of them will have other information. Okay, for example, if you take the GBK, this is a GenBank format, it has information about the sequences and the proteins as well as other features. So you can use the GenBank and then for example count the features. For example, you can count the number of genes, CDS, RNA, etc. So that's something you can do with the GenBank file. Okay, so all these files here, if you go to the Proca GitHub page, which I will leave in the description box, I mean the link, you can get a description of all these files and then that will help you to get a meaning out of what you have. So basically, after annotation, you can use that information to get what genes have been predicted, proteins, etc. So this will help you to understand your data better. Okay, and then you can also do some comparative analysis. If let's say it's bacterial genome, like what we are doing now, then you can compare the features you have with that of other isolates. Okay, so you can use Python to read the GenBank file and then count the features. I've made some tutorials on that and you can watch those tutorials as well. I'll leave the links to those videos in the description. But you can use Python to read the GenBank file and then count the features and then perform some other analysis. If you have multiple isolates, then you could also use Rory. Rory can be used to perform pangenome analysis. I think that's also stated here. So I have a tutorial that also shows you how to perform pangenome analysis. So you can just watch that as well. The link to that video is also in the description box. So I have lots of tutorials on bacterial genomics. So you can watch those tutorials to help you to analyze your data. You can also call variants. That's something that we will do later on. Okay, I've made some tutorials using the command line too, but I'll try and make some tutorials that you can use the Galaxy platform to reproduce. You can also download the output files to your local PC. So you can download them individually. For example, if you want to download the GenBank file, which is this one here, you can just click it and then scroll down to the save icon here and then click it. And then you'll be asked to save it. Okay, so I'll save it on my PC. I have a directory, so I'll just move to that directory. So this is my directory. So I'll just create another directory called Proca Outputs. And then I'll save the GenBank file there. You can also rename before you finally save. So you can rename it. So let's just say, let's give it a sample name. Let's say mu45.genbank or .gbk. Because .gbk is the widely known extension, .gbk or .gb. So I'll use this one here. And then I can save it. Okay, so it has been saved. So you can explore this file, okay, by using your file manager. So let's do that. I'll open the directory. Okay, so this is the file. This is a GenBank file. Now let's go back to the Galaxy platform. If you have multiple files, like in this situation, okay, where we have 12 files, then downloading them individually will be a cumbersome process. So there's a way to do batch downloads. And so to do that, just go to the history side, go to the right side, and then click on this button here, and then search for export history to file. So you can click this, and then here it says no link for history export ready. No history export ever initiated for this history. So that means that this is the first time we are making such a command. Okay, this is the first time we are exporting this history, this very history to a file. So that's what basically this means. So we need to click this one to generate a new archive for this history. So let's click it. Okay, so after clicking, Galaxy will prepare the files for you. Okay, so after that, it will give you the link that you can use to download. So this is the link. So if you want to download the files, just click this. And then it will be downloaded for you. So let's download this one here. So we just save it on our PC. So let's explore the file that we downloaded. So let's open it. This is the file. So it's a .gz file. It's a table, yeah, because of the extension .tar.gz. So you can open it, and then you look at the data sets. Then you see all your files there. Okay, these are the files. So you can extract the content of the files. You also notice that the spirit config.fasta was also included. Okay, so because we are exporting all the files in that history, so we can just extract the contents and then you can view them. Okay, so you can check and then just see each of them. There's a FASTA file, so you can open the FASTA file and then check what is there. Okay, so this one is probably the same as the input file, so we open another one. Let's open the FFN, this one here, and you see the predicted gens here. So that's it. So you can open with your text editor like I'm doing, or you can also explore the contents. If it's a FASTA file, you can explore the contents using tools like Python. Okay, Python has a package called Bioinformatics that you can use to access and then explore FASTA files. I have made some tutorials on that, and I'll leave those links in the description box. So that's about it. We also have the GenBank file, which we downloaded as this one, but we also have this one also here. That's the same thing. Okay, so with the GenBank file, so you can use that to get the predicted features. For example, genes, CDS, tRNA, rRNA, etc. So you can just use tools like Python to explore the GenBank file and then count the features. I've made some tutorials on how to count features in a GenBank file, so you can also watch those tutorials. There are links to those videos in the description box. So that's about it. So if you also go to the GitHub page for Procar, you'll find some description of these files, so you can check that GitHub page out. I'll leave the link in the description box for you to use. So that's about it. Now let's go back to the Galaxy platform. Okay, so we are back now. So you can go back to your home directory, and then with the files, you can also delete them. So if you want to delete, you can just click on this button here, this green button here, to delete the files. Okay, or you can also come to this side and then delete this history. So that will delete everything in it. So you have to be careful with the deletion tags. Okay. So this is a quick introduction to the Galaxy platform, and so I believe this tutorial has been helpful. So that's about it. So thanks for watching this video, and then make sure to watch the other Galaxy or Bioinformatics tutorials.